Hello, everyone, and welcome to our third Share Your Green Design Masterclass. Share Your Green Design is a digital ecosystem of exemplary case studies, research, methodologies, and ideas that showcase sustainable architectural design from around the world. Our mission is to substantially reduce the industry's carbon footprint by providing architects, engineers, and all construction professionals with the knowledge that they need. Masterclass is a space where we invite top experts on very specific topics related to sustainability in the built environment, decarbonization, health and well-being in buildings, and much more. Today, our special guest is Aida Sare. As an architect and university lecturer, Aida has been pursuing passive design for more than 10 years. Her PhD focused on indoor environmental quality in traditional houses. Currently, she works as an architect at her design atelier Gale Studio, where she develops passive design solutions and works with natural materials. Her attention is still on the values of vernacular architecture and the aesthetic balance of this kind of construction with the context, in order to learn more about responsive, eco-friendly, and sustainable design solutions. Today, Aida will talk about passive cooling strategies as an effective tool to provide thermal comfort conditions and minimize the use of mechanical heating, ventilation, and air conditioning systems in buildings. Passive cooling strategies have been used in vernacular architecture for years in response to the climatic conditions of their context. So learning about passive cooling strategies seems necessary, and implementing them in contemporary architecture will lead not only to low consumption buildings, but also creating healthier and more pleasant spaces. As usual, we will have a Q&A session after the presentation, so please post all your comments and questions in the chat on whichever platform you are streaming from, and we will go through as many as we can. As a last reminder, we will be recording the session and will post it later in our channels for your review. Over to you, Aida.
Thank you, Beth. Hi, everyone. Thank you, Beth, and thank you all Share Your Green Design team to plan this masterclass. I wish the previous ones by Kelly and Williams. I really enjoyed their topics, and today I'm going to speak about passive cooling strategies. Let me share the Windows. Mm. Can you hear me?
Yes, I can hear you. We need you to bring a presentation only.
But where's the if you can see the presentation?
You will have to share it again, I think.
Okay. Let me share it again. I'm sorry. I don't know what's the problem.
No problem. You have the share button there.
Yes, it is here.
Good.
So you
Yes.
can see my screen, yes? Yeah?
Yes, perfect.
Okay. Okay. As Beth explained, the topic is passive cooling strategies, and actually, it's around 8 years that we are working on passive design and natural materials. But today I'm going to focus in passive cooling strategies, and that's because it's very hot these days, and we are experiencing one of the hottest days all around the world. In most of the countries, we can see this extreme wave of hotness, and we know that it's because of global warming. And of course, in the cities, we can feel this hotness or more and that is because of urban heat's island effect. And we know that it's because of human activities and extra CO2 emissions. And we also know that the building operation and building material and construction are effective in this global problem, and they have a part. So, us to seek further solutions, and passive design can be one of these solutions, especially uh, in hot climatic zones. And passive cooling refers to any kind of design features that helps renewables source of energy, and they provide cooling and reduce or even can eliminate the use of mechanical equipments and HVAC systems. So, especially in hot climatic zones, that the cooling loads has a major role in energy consumption, they are really useful. First of all, we should know that how passive cooling systems works. They work in two ways. The first thing that they do is preventing or minimizing the heat gain. They do not let the heat gain come into your buildings. And the other things that they do is removing the internal extra heat from indoor spaces to outdoor. So it's better to know how our building captured this heatness, and we should recognize the sources of heat gain in a building. Uh, the first one and the most important resource of capturing the heat gain is direct sunlight through the windows and also skylights. The other source of heat gain is heat transfer via material and building elements like the walls and the ceiling. And the third source is the indoor heat, which is generated by people and appliances. There are six main strategy for cooling the building, and you may find some other categories in different resources. I really like these categories, and this doesn't mean that the others have are something very strange, or they are not right. But I think this is one of the best categories, and as you probably know, it's a very broad topic. And today, I just try to say some main points in each of these cooling systems. And for each item, I mentioned some examples from Iranian traditional architecture, just because I have a better access to the references. The first category is shading. Then we have convection cooling and evaporative cooling, radiative cooling, geocooling, and at last greening. Uh, the first passive cooling system that we have is shading, and this is one of the um, primitive way of uh, avoiding the extra direct sun. And you may have this experience when entering in a sunny day into the street. You automatically put your hand on your forehead, and by this you make a shade for your face to avoid entering the direct sun. This is exactly what this system do for our building, and also for the windows. And you know that, as I said, the windows are one of the most important source of gaining the extra heat. But be very careful when you want to design a mm, shading system. You should avoid entering the direct sun, extra heat, and even extra coldness in cold climate. And you should also avoid glare. But you must be careful about providing the daylight view and privacy, which is the first rule of having a window in a indoor spaces. So try to have both sides. And we have different types of solar shading devices. Um, According to the place of installation, we can have external or internal shading devices. We also can have some solar shading devices in the middle of the windows that I skipped at. And both of them, the external and internal shadings, can be fixed, movable, or even seasonal. And The external shadings are among the most efficient ones. And we have vertical, horizontal, or recessed windows that they are very effective, especially for the windows which are located in the south side. And you know that the altitude of the sun in summer is higher than winter in north hemisphere, and this reality is very helpful to come to a nice results in designing fixed resist windows or fixed external shading devices. You just have enough information about the altitude and also the azimuth on your location, and calculate this optimal overhang depth. The optimal overhang depth can provide the direct sun in the winter that we really need it. Even in hot climatic zone, you have a cold winter, so try to have a prices calculation, or you can even use some software or do it yourself, so prevent the summer direct sun entering the indoor spaces and invite the winter sun into your spaces. We can also use deciduous trees as seasonal solar shadings, and we know that in summer they have a lot of leaves and they can prevent the direct sun, but in winter they lose their leaves, and so they can invite the direct sun that we needed in winter. Here are some examples, and there is one important point about making thermal comforts in a building. You should know that if you want to make a thermal comfort in indoor spaces, it's better to do it gradually and start from outdoor spaces, and start it from urban areas, and try to make it step by step. For example, in this example, you are seeing that there are some shading devices in the alleys and urban areas. It is very effective to start this using these strategies from outdoor to semi-open spaces, and then arriving to the courtyard. And by this you will have a better result because you're moderating the temperature, and you can face the windows and the shading devices to a milder microclimate, so the results would be uh, more effective. We goes to the next strategy, which is convection. Uh, Cooling by convection based on natural ventilation and transferring the indoor stale air with the outdoor fresh air. So they can provide fresh air. They also can provide thermal comfort, and they do cooling the indoor spaces. Also, they can cool the building material. So there are very nice strategy to use, especially in hot and humid climates, because they also can dehumidify the spaces. And as we know that in hot and humid climate, the extra humidity and temperature, both of them are serious problems. So by this strategy, you can decrease the hot temperature, also the relative humidity, and they are very nice for these climatic conditions. And there's two way of providing natural ventilation in indoor spaces. If you have wind flow in your area, so you can use windows, wind catchers, and wind towers. If there is no wind flow in your area, you should make it yourself by buoyancy force and making a difference between air temperature. And all passive solar system works on this rule, like the skylights, atrium, double skin facades, throne walls, solar chimneys, and etc. I put just one example, which is the skylight. When a part of the roof receive heat, the air beneath it become hotter. And if you predict this hole like a skylight for that, this hotter airflow will exit from the upper side of your roof. And if you have a window in the other side, or for better result, having a courtyard, you can have a better result and airflow and for this stack effect. Here in this picture, you can see one example, and this is an skylight at the roof of a house in arid climates, and they can do the ventilation for indoor spaces and make airflow. We goes to the strategies that's based on having a airflow on the location. The first one is designing the windows, and there are different kind of the windows. And to reach the best result, you should find the best orientation and proportion for the inlets and outlet openings according to the condition that you have in your site location. Don't forget the role of the partition, also the type of the shadings and the whole form of your buildings. I just put one example from sash windows or ORC that is a large wooden window with sashes and tinted glass panes. They can control glare for indoor spaces, and they cover an entire side of a room, and you can slide it up and down in a vertical rail. So you have several options to control and choose the best height according to the airflow that you need for your activity that is happening in uh, your indoor room. And as I said, if you have wind, you can also have wind catchers that we call it boadgir in Persian. There are lots of different kind of wind catchers, and they have varied designs. From we have lots of examples from North Africa, West Asia, and also India. And they work in three ways. The first one is that when you have a favorable prevailing wind, so in this region, you just put a windward opening for your wind catcher and invite this airflow into your indoor spaces. But if this airflow is not favorable, so use a leeward opening to the ventilation and use this negative pressure to vent and make an airflow and convection in indoor spaces. And if there isn't any wind in your area, again, you can use the buoyancy and stack effect to make convection cooling by a wind catcher. I put some examples from several kind of wind catchers, and as I told you, according to the characteristics of the wind in the area, including its speeds and the height, you can have different types of wind catcher. And here you can see one of the most primitive and simplest kind of wind catcher that are located in a village that have a windy um, condition, especially in summer. And this is very nice because these small wind catcher are very simple to build, and every room can have one of them, and they work very well, and they can provide thermal comfort for the rooms beneath it. Uh, and this is an example of one-sided wind catcher, which are located in Ardakan city. It's a city near Yaz that have a very horrible climatic conditions. It's very hot and very dry, and from three direction, they have a wind that have lots of dust in it, but they provide and find a way to use these one-sided wind catchers through the uh, favorable prevailing wind, and they can provide thermal comfort by using these wind catchers and also other passive cooling strategies. And these houses make a very pleasant places for live in these harsh climatic zones. You can also have two-sided or three-sided wind catchers, but there are rare examples of that, but more common wind catchers are the four-sided wind catchers, like this one that you are seeing, and they are built mostly in Yas City, and these wind catchers are usually tall, and they are made by earthen materials, and they can cool the wind in some extent. And this is another kind of four-sided wind catchers that they are located near sea. They are located in south of Iran near Persian Gulf. And comparing to the previous ones, they are wider and shorter. And they just want to direct the breezes from the sea to the indoor spaces, and they also works very well. Uh, we can also have two-story wind catchers like this one. They are very well, and they can provide airflows in any condition and situation, as they have lots of partitions in this shaft, and there are some opening beneath it, and you can control the amount, also the direction of the airflows, but they are not easy to make, and they are more expensive, of course. So you cannot find lots of example. This is one of the exceptional two-story wind catchers. You can also have multi-sided wind catchers like this one that is located in Dolatabad Garden in Yaz City. This is one of the tallest wind catchers that we have in Iran, and it has eight different sides, and at the same time can catch and also vent the airflow due to windward and leeward openings that it has. We go to the next strategies, which is evaporative cooling system. And we know that water evaporation drives in heat and can decrease the air temperature while improving the relative humidity. So, this is one of the best strategies for hot and dry climates, because you have um, uh, another two serious problem. And in these regions, you have hot air temperature, and you have a lack of humidity. So, by using evaporative cooling system, you can decrease the air temperature and also increase the relative humidity. So it's a great chance to using these systems, and it would be a very nice solution. And evaporation can work in two ways. In direct phase, The evaporation happens in the desired space, and you have humidity in that space, like using the wet curtains or indoor pools or courtyards. But in indirect way, the evaporation happens in one of the building elements, like the roof or the walls, and make that element cool, and then you just use the coolness of that element, like having a roof pond or spraying water on your roof. This indirect way is more expensive, and it is some detail and also insulation. I just put some example from direct evaporation system. Here you can see an indoor pool, and this is a pool in a courtyard. The plants also help the evaporative cooling in the courtyard. And there are some examples of combining convection system with evaporation that will have a very nice result. Like this one, which is a kind of wind catcher that they called malqaf, and I think they're originally from Egypt. And they can catch the airflow, and as you can see, there is a water pot here that it can do and benefit the evaporation. They also can prevent entering the dust, which is maybe be in the wind of your regions. So this is one of the nicest strategies for dry climatic zones. There is another example of combined system that benefits the convection to the wind catchers. We can also see the geocooling in the basement, also the evaporation from these underground water canals. And yeah, this system can provide humidity and helps to have a pleasant airflow in indoor spaces. We go to the next strategy, which is radiative cooling. And this strategy is based on the heat transfer between a hotter body, that here is the building envelope, to a body with lower air temperature, which is night sky here, via line wave radiation. So the nocturnal radiation cooling system working in a way that your whole building envelope can lose its heat to the night sky and make indoor cool at night, especially in clear and cloudless sky of a hot and dry climate. Here is an example from cool roofs. You can also benefit the cool roofs and cool surfaces by using the high albedo materials that have the light color, and they can reflect the direct sun during days, and they can decrease its loss at night also. And you can see here a picture from Concord, again near Persian Gulf. And these houses are made of local material, and they are plastered in lime and clay plaster, which has a light color near to white. And they also benefit the wind catchers, semi-open spaces, and courtyards, and they are very responsive to these climatic conditions. We go to the next strategy, that is geocooling. And geocooling benefit the characteristic of Earth, and this fact that if you go around 6 feet underground, you reach a relatively constant temperature, which is near to average annual temperature of the area. And that means that you have cooler spaces in summer and hotter spaces in winter, especially in arid climatic zone, whether it's cold or hot, that you have an extreme temperature variation between day and night and between winter and summer. Geocooling works very well. There are three types of geocooling. You can have air sheltering, underground buildings or earth-bearing buildings. If you want to use geocooling, be very careful to provide enough sunlight and air circulation for your indoor spaces. It's very important because this can be a struggling problem when deciding to have an air shelter building. There are also different kind of strategies for providing heating and cooling via ground sources like heat pumps and like open loops, lake loop, closed loop. That I'm escaping that. And here is just one example from underground buildings. You can see a sunken courtyard. A sunken courtyard is a courtyard which is located below ground level. And by using it, you can supply daylight and air ventilation, also view for the underground rooms. Uh, we are going to the last strategy, which is greening. And you can use this strategy in any climatic conditions and benefits the beauty also having the fresh air, reducing noise pollution, enhancing biodiversity, and etc. Every benefit that is goes to having a tree or vegetation. So uh, of course, for hot areas, this is one of the best techniques because vegetation can absorb solar radiation, can make shades, and they can release moisture into the air through the transpiration. So they can moderate the air temperature and also humidity. Yeah, they can have different types. You can design the gardens, vertical gardens, roof gardens, courtyards, green roofs, green walls, bio walls, and etc. In this picture, you can see a courtyard in an arid climate, and you can see the fruit trees here, the pomegranate trees, also the fig trees. um, they are adapted with with this climatic condition, and they also can provide food for the inhabitants. It's very important that what kind of the plants and trees you choose for your gardening. For sure, try to choose the local trees and plants which are more efficient, and they are more adapted with the weather condition of your regions. Here is another exceptional garden which is located in the middle of desert. This is Shaz de Mahan Garden or Prince Garden, which is near Kerman, and again has a very arid climate. And this is one of the historic gardens. And by considering some strategies like finding the best location and transferring water from the mountains with underground canals to this garden, choosing the best planets, and also uh, having a massive thermal wall around the garden. Mm, yeah, you can see that there is an incredible man-made landscape that make a deep difference and make a very different microclimates. It's just like a paradise in the middle of a desert. And this is sustained till now. It's around, I think, 200 years, and it's very notable in the building man-made landscapes. Uh, The best strategy to using passive cooling strategies is combining all of them. Do not hesitate to mix all of these strategies together to gain the best results. Uh, You can see one of the best example of using all these methods in a house, which is Abbasian house. This house is located in Kashan, again in a very harsh climatic zone, very hot and very dry. And it's better to say that this building is just like a residential complex, because it doesn't belong to one family, and there are several families that lived in this residential complex. And as you can see, there are five different courtyards and around 3 or 4 stories. Now you can see that there are some wind catchers. You have domes that can provide shade for you. Also, you have lots of semi-open spaces and shading systems, combining with evaporation systems, and all the strategy that we speak about today are used in this place, and they works very well. They really works like a miracle. And this house is famous for the aesthetic values in architecture, but for me, it's just like a passive cooling museum, because you can use all of these strategies in different types, and in a very beautiful way. And in fact, they were incredible. And exactly in the day that I took this picture, it was in July, in one of the hottest day in summer. And I feel like having a hit a strike when we were in the street. But when entering this house, and exactly in this place, which is one of underground rooms, I really wondered how these kind of strategies can do uh, can make this comfortable and also beautiful places, and how they can work this well without using any kind of mechanical systems. It's it's very very mm, surprising, incredible, and very beautiful. There are just 2 points that I like to say as final words. The first item is mm, having a holistic idea. Mm, this is another picture from Abbasian house, and as I told about this house, I know that there are lots of same example in traditional architecture in the other countries also, and they do not just respond the climatic condition, or just solving the structure, or just paying attention to technical points. Um, I think that this kind of architecture is about creating responsive and functional spaces, and also make it better sense for us. And they provide high quality spaces for living, and they also respect the environment. So it's very important that in this harsh climatic zone, they solve this problem. And beside it, they present a very high quality spaces for living. I think it's very considerable. And the last thing is that find the best solution for your own location, and your context in each project is very important. And this picture is a small house that belonged to a single family in south of Iran, and they used a wind catcher, and they used local material to build this house. And there is a semi-open space, and they provide cross ventilation and convection. They benefit the radiation. They also have some local trees to provide shade and benefits the greening. And this house also was one of the most beautiful houses that's I saw, and I think it has a kind of beauty and some originality, which is very valuable. So uh, find the best solution for your own context, and in each project, detect the problems, the financial problems, the climatic problems, and see what you have and what are the potential of your location, uh, what kind of technique or what kind of material you have on your surrounding, and create the best solutions and enjoy it. Uh, Here you can see the references, and yes, it's finished my presentation, and I'm here to answer the questions.
Thank you very much, Aida.
You're
Was
welcome.
a very interesting presentation and beautiful images, beautiful landscapes, and beautiful architecture.
Thank
It
you.
was very pleasing to see it. So, thank you very much for sharing all
You're
those
welcome.
examples. We are, I mean, here in London, we don't see this type of architecture. So, it was like traveling to Iran with you. Thank you very much.
You're welcome.
And I think, yeah, so I think this is also an important point, I think, in understanding that now we have a changing climate and a warming planet, and we need to adapt to new climates and hotter uh, places. So it's not only important to learn from the vernacular architecture from the places we are in, but also very important to learn from the vernacular architecture from other places, from hotter places, and adapt those strategies to our contemporary architecture, even though we are in a different um geographical location. So I think it's really interesting to show these examples uh, to other places and spaces like this one at Share Your Green Design, where we try to share um, green designs across the world, and yes, from across the world to across the world. I think this is very important, so thank you very much.
Yeah.
Also,
And I really thank you, Share
yes,
Your Green Design, to provide this platform to sharing. Yes, it's about sharing, and it's very important. Thank you very much.
absolutely. No, thank you for sharing. Also, I wanted to highlight when we talk about, for example, at the beginning of your presentation, you were talking about windows and how to shade these windows. So from the London architecture or the temperate climate architecture, windows are usually the interface between the outside and the inside. So there are
Mhm.
so many things to consider in the facade, and in particular in
Exactly.
building
Yes.
windows.
Yes.
But in the case of this architecture that you were showing today, it was very interesting to see how it's not only about windows, but you need like these in between spaces
Mhm.
to make so having the not only the connection to the outside, but the protection from the outside, because these climates are much hotter,
Yeah.
or well, not only hotter, also colder. Is such a big difference in the inside and the outside, that you need these spaces where you need to have very shaded spaces, or like a lot of space for either water elements or vegetable elements, that this changes uh, considerably the mindset you need for this protection from the outside, at the same time connected with the outside. And I see it so valuable to learn from these things. Very, very interesting.
Thank you.
So yes, thank you for these images, for that as well. So let me see if I have any other question, comments myself. Um, yeah, I think it's about that. It's about the balance between connections and protection and creativity and learning from different locations. So I will go now through the questions from our audience. Um, so the first one, can these strategies be applied to a building where cross contamination can occur, such as hospital, for example?
Uh, yeah, for hospital, and
Yes,
that's
I think
you
this
need
relates to ventilation
you
when you
need
talk about
lots of kind of you need control. You need to have control. Yes, you can use these strategies. Of course, not in surgery room, but for the other parts of a hospital, yes, it's better to use them. But you need add some technology and use high tech uh, to make some controller and have some smarter systems. The examples that I show you were mostly from traditional architecture, and just to explain the function of these systems. But we can also use this function in a modern way, and for the places like hospital, you need to add some controller to these strategies, and you should also predict some maybe you need to get help from HVAC systems as a backup, because hospital, yes, this is an exceptional function, but for at that in hospital you have different parts, and there is a room for some patient, there is a room for doctors, or the one that want to visit the patient, and also the surgery room. So not for surgery room, it's also the same as daylighting systems. You cannot use daylighting in a surgery room, but it's better to have it in the patient rooms. So if you want to go through have a green hospital, and to provide a better sense for the patient, yes, it's better to use passive design in any climatic zone, and also benefits all the natural aspects, like providing the daylight views, and also benefit the passive cooling strategies, but in a way that you have more control on it. Yeah, and it needs some details in designing when you want to use these strategies in a place like hospital. Do not put a wind catcher in the middle of the patient room. You can use this wind catcher in another way. Yeah, you do, exactly in Abbasian house you cannot find the opening in the wind catchers. You cannot get that how this place is cooling. You don't see the channels. The channels can go underground. Yes, you can use it, but not in this way.
Yes, I totally agree with you. And also, it's true that there are spaces that need to be highly controlled. And for those spaces,
Yes,
there are some strategies that you cannot use, and you can use some mechanical input there.
yes,
But those spaces are the very few in comparison to all the other spaces that we, indoor spaces that we live on. So yes, for those exceptions, not for the rest, yes. And also, if you think of when we occupy those spaces, a surgery room would be used for a very particular activity. The rest of the time, the patient and
yes,
the workers will be in other spaces, so they will fulfill their health and well-being better in spaces that are with more daylight, with other types of ventilation. So yes, it's a matter of balancing as well in the end. Uh, Let me go to the next question. Why did we move away from these passive cooling strategies around the world? At what can we do, and what can we do to bring them back?
uh why we do not use them?
Yes, anymore. So why did
Yeah,
we
this
stop
is my
doing it?
question too. because they are very efficient and they really works well. There are uh, different things that like lots of other things that we lose after industrial revolution, and now we are trying to coming back to them, like natural materials, low tech, or any kind of passive strategies. After a while, we forget how to use it. So nowadays, we do not have enough knowledge, enough technician, and we do not how to use them. We do not have enough practice in our universities toward these matters.
Okay.
And of course, there are very old techniques and they've worked very well for years. But nowadays, it seems that there's something new for us, and but it's never late. If you believe in the function, you can find a way to use it, learn it at first, learn it, and then use it in your projects. Even in every kind of projects or renovation projects or any function, there's a way. If you have um, enough knowledge and you learn enough, know enough about them, you can use them. Yes, and it's better to bring them back together.
Totally agree. Yes, thank you. Then we have two very similar questions. So, one, how can these strategies be used in dense urban environments? Any particular consideration?
Mhm.
And the second one, do you have any examples of these traditional methods incorporated into contemporary urban buildings?
Uh, Example of traditional method incorporate. Yes, there are lots of this example in contemporary architecture. Um, Maybe, of course, according to the needs of each projects. Maybe the shapes are a bit different, but yes, you can find it if you search the wind catchers. You can find some contemporary example or any other types of passive cooling strategies. I do not have it in my mind now. I think maybe Doha University has a lot of wind catchers, and I also see some examples in European countries. Um, yes, there exists this kind of examples, but it's not uh, too many examples in contemporary architecture. But we can see that it is day by day increasing using this kind of strategy because we really need them. And
That's great.
the first question was.
No, so it was about because the pictures that you showed were mainly rural or in space
Mhm,
or like buildings with a lot of space. But if it's in a dense city,
mhm. Yeah.
how we can adapt
Yeah,
these strategies to
as I told,
dense.
if you have this chance to provide uh, these techniques from outdoor and started from outdoor and urban areas, then they works better rather than just finding and using the passive cooling strategy in a single building. And unfortunately, we do not have enough responsive urban areas, and it's better to start from there. And I know that there are lots of strategies for landscape and urban designers to make more green spaces. I mean, more responsive to climate, not the green color. But yes, if we have a nice cooperation with urban designing and at first providing and start solving this problem from outdoor to indoor, then the result would be better. But mm, uh, maybe we do not have yeah, enough chance to solve all these problems together. So start
Yes.
from where you are. If you have an interior renovation project, try to use it. If the scale of your project is bigger and it goes to the architectural scale or urban area or landscape architecture, so it's a chance for you to get help from these strategies and do it in different scales, and in that way you will go to a better results.
Great. And probably work interconnectedly, right? From the big
Yes,
scale to the small scale. That
yes.
will always help. Thank you.
You're welcome.
Another question. I think we have time for a few more. Thank you for your excellent presentation. The high thermal inertia of the building is one of the main passive cooling strategies, but you have yet to mention it. Could you let me know if you include it in the other categories?
Where is the question? Uh, Excuse me, can you show
I
the
can read it
question?
again.
Yes,
I
thank
can
you.
read it again. The high thermal inertia of the building is one of the main passive cooling strategies, but you have yet to mention it. Could you let me know if you included it in other categories? So, how to include the thermal inertia within this passive
The
cooling
high
strategy?
thermal interior of the building, yeah,
Yes.
like the thermal masses and materials. It,
Yes. So, I
mm-hmm,
assume that one of the strategies
yes.
that you mentioned included it, the one that is like the
Mm-hmm.
sunken
You
patios.
can benefit it in all the strategies to making the devices, for example, to making a wind catcher. If you use a thermal mass, the results would be very better. For making the walls in the cold yards or the whole building materials, then they will work better and you will go to a better result. And you know that you may know that one of the focuses of our researchers goes just to earth and material. I think the last year I had kind of a webinar in Share Your Green Design, and I just speak about the characteristics of earth material and thermal masses. They are really effective. Yes, they have a very main point in all kind of strategies, and it's better to use them. And I don't say combining them, but I think it's not something separate. It's something very essential. It's using thermal mats is not only works in hot areas but also in cold areas. And the life cycle assessments and the recycling and the other good points that they have is make us going for them and using them. Yes, if you mean thermal mass with high thermal interior. Yes, who is this question goes to George
This
Fernan.
question is there in the screen. It will be also posted on LinkedIn, so you can also
Yes,
chat in the answer, and everyone will
if
see
I
it.
didn't answer you in the best way, or if I didn't get your question, don't hesitate to ask it again.
Thank you very much.
You're
I
welcome.
will ask you the last question. How can we intelligently incorporate water in a manner that addresses the water crisis? How do we
Hmm.
integrate this feature into sustainable design?
Yeah, this is a very good question, and
And it's sorry, it's interesting to see that the images that you showed before, the context were very um, arid, and still you
yes,
had some water features. So
you
it's good to learn from that.
in that era they had a very wise kind of reaching to a technology and having some underground water canals that called qanat, and they solve this problem, and they provide the water from the mountain areas, and they bring it from underground canals to indoor cities. So by just like protecting the water underground, if it wasn't underground, that like aqua channels, so it evaporates and we do not have any water till now. But they provide it very wisely. And nowadays, we have a lot of problems and water crisis, um, and we do not have a nice water management. So um, this goes day by day, a very huge problem. But the strategy that they used in traditional architecture was using from qanats, and also providing shade wherever they wanted to use water as an evaporative cooling system. So if there is a pool in the courtyard, there is a shading from the trees, or even a man-made shading through it to protect it. And this evaporation happens slowly. Or you have indoor pools, and there are some strategies to reuse the water that evaporated in, if you reach technology, and you can use some smart techniques for evaporative coolings, like oxygen walls, bio walls. You can reuse the water and make a closed loop to use the water again. And beside it, of course, you need the water management from the cities to any single
Of
buildings.
course. Very, very interesting. Thank you very much.
You're welcome.
So we'll have to leave it there. If we have more questions, maybe we'll be able to respond them over LinkedIn or
Yes,
YouTube.
for sure. If you have any question, you can connect me in LinkedIn. I
Thank you very much.
thank you again, Betty, and all share your green design team.
Thank
So
you very much.
thank you
Yes.
and have a nice day.
You too, and thanks everyone for the great questions and for joining this masterclass today. As I said before, these sessions will be posted online, so check the website shareyourgreendesign.com and subscribe to our channels to keep up with this and other contents that we are constantly sharing, such as the latest projects, news, research, events, competitions, student work, and job adverts. Also, if you have projects you want to share in our platform, please get in touch with us. We even have a section dedicated to student projects and research. And if you have any comments, ideas, or just want to collaborate with us, please get in touch as well. Thank you, everyone, and see you again soon.